Welcome to Finding Inverses Graphically and Algebraically. Let's get started. We can find the inverse of a function both graphically and algebraically, which is what we'll do here. But an inverse function is a function obtained by interchanging the dependent and independent variables. So that means switching the x and the y values, right, which I'll show you in a minute. The other thing that you'll notice about an inverse function is that it's a reflection over the parent linear function. Okay, so reflection over the parent linear function, which is y equals x. So this right here is y equals x, the parent linear function. Okay. So what that looks like on a graph is if you had a graph that kind of looked like this, and I'm not going to draw it perfect here on this example, well then you would have an inverse like that green line. So this would be your original. Okay, and the inverse function reflects over that y equals x line. All right, so this is a mirror image of this original function. So we're looking for the inverse function. All right, so here are the steps to finding inverse graphically. You can pause the video and write all the steps down if you'd like, or you don't have to write the steps. You can just do the example with me, and you could come back and put the steps in, or whatever you want. Okay, remember they're your notes. All right, so let's do this example, and you take this function and let's find its inverse graphically. You can draw this graph here if you want, and tables if you want to. You don't have to, but let me go ahead and start. So the first step from that other page was to graph the original. So I'm going to graph this like we know how to graph. We find our y-intercept, which is 2, and then we go with the slope. Up 2 over 3, up 2 over 3. And I'm going to give myself a couple of points the other way, down 2 over 3. You only need a few. I'm just getting a couple of extra. All right, so there's my original function. So we graphed the original. Then we want to get some points from this line. Okay, so this point right here would be negative 3, 0. And this is 0, 2. And this right here is 3, 4. All right, you don't have to put it in the table. I'm doing it just so it looks a little neater for you guys on here. But the second step was just to find some points. All right. Now you want to find your inverse points. That's the third step. Inverse points, remember from that definition on the other page that it's when you interchange the dependent and independent variables, which is just means switch x and y. So if I have negative 3, 0, right, as one of my points, then my inverse point would be 0, negative 3. Just change the places of the numbers. You take the sign with you. So instead of 0, 2, my inverse point would be 2, 0. That looks like a z, but it's a 2. And instead of 3, 4, then I'd have 4, 3. All right, so that was my third step. Fourth step is to graph the new line using these points. So I have 0, negative 3 right here. Then I had 2, 0, and 4, 3. And if you notice, it should be that mirror image, that reflection over that parent linear function. And I didn't draw my line very straight, but you could use a ruler. So this is the original, here's the inverse. It looks like it was reflected over that black y equals x line. That's what we're looking for. Okay, so the very last step is to find the equation. And you can find the equation of a line, right? You've got your y-intercept, which is negative 3. The inverse always has this little negative 1. Just to show you that it's not the same function, it's the inverse function. But we take our y-intercept, like you said, which was negative 3. And remember, you want it in that slope-intercept form, which was mx plus b. There's my y-intercept. We're looking for our slope. From this point to this point, I went up 1, 2, 3 over 2, rise over 1, so 3 over 2. So I found the inverse of this original function. I found its inverse by using the graph. All right, if you need to review that example of finding the inverse graphically, go ahead and do that. If you're ready to move on, then here's steps to finding inverse algebraically. And again, you can pause the video and write all the steps down if you'd like, or come back to it if you need to. All right, so let's do this example. It's the same one we used when we found it graphically, 2/3 x plus 2. And let's just find the inverse algebraically. So we know what the answer should be. So first step is to change the f of x to a y. It means the same thing, but we need it a y in this case. All right, the second step is to switch the places of the x and y. So instead of y, you write an x, and instead of x, you write a y. So you don't take any numbers with you or anything like that. Just switch the places of the x and y. Then your next step is to solve for y. Okay, and you want it in slope-intercept form, so that's why we're solving for y. So I'm going to subtract 2. And in this case, you're dividing by 2/3. Remember, dividing fractions is the same as multiplying by the reciprocal. So we want to multiply by 3/2 on both sides. All right, so this cancels it out, and you get a y over here. And then we're distributing, so we have 3/2 x, and then minus 3. And then your next step is to change y back to f of x. Okay, so we change it here, let's change it back, and I'm just writing it the other way. And then you need that little -1 to indicate that it's an inverse and not the same function. Right, and there is the inverse, and that's how we found it algebraically. Again, inverse was interchanging the independent and dependent variables, right? We just changed the x and y. And that's it. Now the last step we have in there is to check it in your calculator. If you'd like to check it in your calculator every time, you should see the graph version. So you should see exactly what we just did on that other slide in your calculator. That way you can tell it's a reflection over that y equals x axis. So what you would do is in the first part of your graph, you type in the original. Okay, or you could just write original. So it applies for everything. And then in y2, you're going to put in an x because you want to see that parent linear function. And then in y3, you'll put your inverse function. And it should look like an inverse, right? That reflection over that y equals x line. Now go back if you need to, see any of these examples again, and don't forget to do your questions and your summary. Thanks for watching. Bye.